Oh, okay, I guess you're gone, so it's probably working. Hi, everybody. My name is Pierre-Yves Ricau, but I like when people call me Piwai or Pierre because it's just easier to pronounce. And apparently it works, so that's amazing. I started the recording, and I think we are ready to go. So I'm going to do a little bit of setup on my end. Okay. I think this goes here. Sorry, I'm setting up my windows. All right, so I'm gonna try to not take too much of your time. This isn't a traditional presentation in the sense that I'm not gonna go through slides. I want to kind of go more live and do some demos. Let me see if I can. I guess I can do this. I don't know about the chat. Okay, cool. I can do this. Great. So I'm an engineer at Square. I'm the author of LeakCanary. I'm going to assume you didn't randomly click on a link, and so you probably know what LeakCanary is about. And therefore, I don't need to explain that to you. However, you may not know about the details of LeakCanary 2. Maybe you're still using version 1.6. Maybe you inherited a project and haven't done the migration. So I'm going to talk a little bit about that, and then we'll dive into some use cases. So let's see. So to do this, I'm going to try some cool setup that I did. So if I go with this, let's go with the emulator view first, and maybe with this is cool. I'm trying, the live streaming tools, and I'm not very used to use them. So we'll see if it works. Great. So what I'm showing here is my IDE, and what I'm going to do is actually start the profiler. So you can see my phone here, and I have an app, and this app contains leaks, and I have installed LeakCanary in this app. So if I start the profiler here, we should be able to see in a minute the profiler. So it takes a little bit of time. Okay, so we can see the memory here, and so you can see it, this is an Android app. I have leaks on my app, so if I rotate the screen and do it a couple times, then the memory increases because we are leaking the view hierarchy. And as you can see, it didn't immediately dump the heap. So with LeakCanary 2, we track retained objects, and then when we reach 5, we start dumping the heap. So here it said found 6 retained objects grouped as 4 distinct links. So I also have a button where I can just instantly recreate the activity and create leaks. I'm going to do this a couple times. So you can see here it progressively increases and says, oh, I have 1 retained object, 2 retained object, and then 3 retained objects. Cool. So the first thing I kind of wanted to talk about was how with version 2 we introduced the ability to use your laptop as a way to dump the heap and do the analysis instead of using the library. And I realized that I did not include this in terms of window capture, so I'm going to add terminal as a window capture. It's going to take me hopefully just 1 second. Where is iTerm? Cool, so this is what iTerm is. Just gonna check, yeah, you can see that. Okay, so there's this new command line tool that you can install using Homebrew, and it's called LeakCanary Shark. So if I type brew install LeakCanary-shark, it's going to install LeakCanary Shark. It wants to update Homebrew for some reason. But it turns out I already installed LeakCanary Shark anyway, so there's nothing to do. But then I can do shark-cli. So I'm realizing that you're probably not seeing what I'm talking about. Are you seeing? Yeah, you're seeing it. Okay. So, and I'm going to change this to be fitting the screen. Fit screen. Oh, okay. Cool. So shark CLI, it shows a nice shark eating a canary, but it's got it's a command, and it basically can talk to the connected device. So here I have my phone connected, and I can do shark CLI -pcom.example. That's the package name of my app. And then I just do analyze. Oh. And at this point, it should be doing stuff soon. Right, so you can see it's dumping the heap on that process and copying that file to the SD card. And that's interestingly taking longer than usual. But yeah, then it actually, so you can see text dump. It did the analysis directly within the terminal. It's actually just a jar. And then you have the result of the analysis, and you even have the heap dump file in your local folder if you need it. That's just one example. I'm going to remove that terminal now and hide it. Nope, not that. This one. Okay, so let's see. We've got the memory profiler running, and one of the big things that happened with LeakCanary 2 is that the analysis has a much lower memory footprint than it used to have. And so you can see the memory increasing, it's parsing the heap dump, but overall it didn't add too much. You can see that, well, the Java memory went from 8 to about 30, I guess. And then if I do GC, it should go back down. Yeah. So that's cool. It means it can run without impacting your app too much. So now let's, I'll just switch here. I guess I want to switch to this, and I'm gonna move this, and let's look at the result. So when I click on that notification, it brings me to a screen where you can see some information about the analysis of the heap dump. So you can share the file of the heap dump. You can then see that it found 3 distinct leaks within that heap dump. And so one interesting thing is that every heap dump, it finds a number of leaks inside them, but then it can group those leaks. And so if we go back, we can see that we have the 2 heap dumps that we've made so far on that screen, but on the left tab, we have 4 leaks, or actually it's more than 4 leaks. We have 4 distinct leaks, but actually if you sum all the numbers, you can see 3 plus 3 plus 2 plus 1, it's 9. So we have 9 leaks that were grouped into 4 distinct types of leaks. And that's one of the new features, is this ability to group and give you counts. So instead of a list of 100 leaks, you just have the actual number of bugs that you have. Each bug is one entry in that list. And so if I go in, I can start looking at the report. And there's one of the key things that's changed is how we surface information, because here we try to show you where the potential cause is, and the potential cause is one of those fields that is, or reference that is currently highlighted in red. So how do we do that? One thing you might see is that under every instance or object, there's a little leaking no and leaking yes tag. So it says, fonts contract is a class. A class is never leaking. Example application is the application singleton, so it's not leaking. The application is never leaking. Then it goes down, it says, well, the textView instance is leaking because it has an mContext field that references the destroyed activity. Then it says mContext is an instance of main activity with mDestroyed equals true. And that tells you that this TextView is leaking. And then so basically, because before it's not leaking, after it's leaking, we know the problem is in the middle, and that's why it's highlighting those elements in red. And those elements highlighted in red is what's used to group memory leaks together. And then there's a few more interesting things, like you can see that view.mid has the actual name of the view, the resource name of the view, r.id.helpertext, and that's useful to identify where the leak is happening. So that's pretty much it. One thing that's kind of interesting is a new small feature. If you have LeakCanary in many apps, you start getting a lot of LeakCanary icons showing up in the launcher. I only have one here, but potentially you'd see several. One way to work around that is that we now add a dynamic icon. So when you long press, you can directly access the LeakCanary app or activity. But you can also long press on that, and then you can drop it. And now you have the LeakCanary icon, but with your apps icon in small. It's a default. It's a feature. It's an Android feature. And that means that it's really easy to identify, okay, the leaks for this app are here. One of the nice new things in LeakCanary 2 is this new UI. So the UI is organized in kind of 3 tabs. The leaks, so it's grouped by leaks, or the heap dumps, which is every time I dump the heap. You can dump the heap immediately by clicking dump in now. You can import and heap dump from another device. It's very useful for me. And then there's this about section that provides some information about which app it's actually running in, which is useful when you forget, you have this LeakCanary icon and you're like, I don't remember which app it is. Or if you ship LeakCanary to production, at least people contact me on Twitter saying, why did you add a bird icon to my phone? And I'm like, it's not me. Look in this tab. This is where the problem comes from. Anyway, so one of the things, so you can see also that it's highlighting new versus not new, and so it's using these red parts to identify a unique signature for the leak, and then that way it also knows if that signature is new to the device or if it's been seen before. So here, once I actually read through the leak and I go back, it's not new anymore. And one of the interesting things that you can see is that there is the top has a set of actions. It's not the best UI in the world, but it's a textual UI, best I could do at the time. And so it has share leak trace as text or on Stack Overflow. And if you click on Stack Overflow, it's going to copy the leak trace in your the clipboard, and then redirect you to Stack Overflow, and you can just paste the leak trace in there and create a blog asking for help, post asking for help for that specific leak. And so I thought that today it would be interesting to go on Stack Overflow and look at some leaks there and see if we can figure out what's going on. And the point of that is to show that that we actually, it's actually fairly easy, even if you have no idea whose code this is and you're not part of that team. So let's do that. And for that, I will go to browser mode, and I will unplug this. That way, that's resources used. Cool. So let's look at a first leak on Stack Overflow, and I hope that it will all make sense. Okay, so here we have a leak that said the Stack Overflow post that says bottom sheet dialog fragment shows a memory leak in LeakCanary 2. I'm not sure why. I'm not going to read through all the text, but I'm going to jump to that leak trace because I think it's interesting. So it says, okay, one application leak. We don't really care about the signature, but this is the leak trace. So it shows you that, okay, the GC root is a system class. We actually don't care about any of that. The way that I read those things is I immediately jump to the part with the squiggles because I know there may be more than one, but I only need to look at those. This is like everything before that is not leaking, everything after that is leaking. So here it's telling us, okay, there's a main activity, there's an instance of main activity, and it's not leaking. It's not destroyed. Okay. And then it has a field called bottom left fragment, and that fragment is leaking because it's a long sentence. So it's one of the new features that we're working on in the future release of LeakCanary, where we are going to wrap lines because on Stack Overflow it tends to be too long. But anyway, if we can read here, this fragment receives fragment that undestroyed. Okay, so the activity is not leaking. It has a field that contains a reference to a fragment that is destroyed and therefore leaking. And then you can see, you look at the code. So I always just start with the leak trace and then only I look at the code. I don't try to randomly poke at the code. And here you can see that this activity has a button nav fragment, which is set in onCreate and is never unset. That's the end of it. So that's a pretty simple and probably obvious leak. The user just needs to set button nav fragment to null when the fragment is destroyed. So the fragment could call back from its undestroyed listener, or you could set a fragment lifecycle callback. There's a whole bunch of ways to support this, but basically that's the source of the issue. So that was that's kind of a warm-up. I'm trying to go in easy. We have a chat right there. I sure hope I'm still connected. But if you at any point you're like, oh, this wasn't very clear, don't hesitate to ask questions in there. We'll have the Q&A in the end for general questions. But if something's not clear, like immediately when I'm presenting, please ask questions. I might not see it immediately, but I'll try to pay attention. Okay. And I'm gonna come back to the chat. All right. So let's look at a second one, a bit more interesting. I'm trying to get us to more and more interesting stuff. Okay, so let's ignore all of the text. There's some code, we can ignore that and jump to the leak trace. So here we see no. And then, so I'm looking at when I say no, I'm talking about these pieces. And then we can see unknown, so we don't know about the state of these objects. And then we can see, oh, there's this blank fragment that is leaking because blank fragment receive fragment undestroyed. Okay, so what do we got? We can see that before, so everything underlined, like before there's this user profile fragment and it's not leaking. Okay, it's a live fragment, everything's fine. It has a field called transaction. And then you get into some Android X code. Okay, hey, what is a transaction? It's a backstack record. I'm just checking because I'm being pinged by the admin, but it's fine. And what is a backstack record? Well, it has an array list, which is backed by an array, obviously. And then that backstack record is holding on to a fragment transaction $0p, which is some sort of object, which itself has a fragment. Okay, so when you start a fragment transaction, you pass it a fragment, it makes sense that a fragment transaction, backstack record, has fragment instances. But clearly, it sounds, but that fragment record is an old instance that's been detached, so it shouldn't be around anymore. And clearly, the bug here is that this user profile fragment is holding on to an old transaction object, backstack record object, and that record has the destroyed fragment. And you can actually see if you scroll to the code, he's doing this. He's creating they are creating a blank fragment, then starting a transaction, and committing the transaction. We don't see their activity code here, so we don't know exactly what they're doing with that transaction, but you can bet that they're setting it on this user profile fragment.transaction. And so the fix is obviously to not do that and figure out a way to clear this field whenever the fragment is destroyed. Sorry. So let's move on to something that's a little bit even more interesting. Okay, I can't type. All right. So what's going on here? So this says the same. No. I get really no is really exciting for me because I have a 16 months toddler and he recently learned to say no, and so he gets really excited and he's always like no. So if you hear me doing that, that's why. So here I can see, okay, same thing. I have I look for the squiggles. There's only one, so the code should be pretty obvious, but it says there's a login fragment. It's not leaking. And then there's a material button instance, and it is leaking. How do we know that? Well, the view is detached. It has a parent. We can see that it's been attached at least once. That's mwindow attach count. Its name is button login. Cool. And then this is where we're going to scroll to the long line. So this fragment has a fragment manager, so it's alive. So what's going on here? Well, fragments have an interesting life cycle, and they can be created, they can be destroyed, but there's also an intermediary life cycle where they have a view, and then they don't have a view, but they're not destroyed. And so these callbacks are, uncreate view, undestroy view, undestroy. After undestroy view, fragments are supposed to let go of any reference to their views. So what's the point of undestroy versus undestroy view? Well, fragments can go in the backstack, and when they go in the backstack, they're not destroyed, but they receive the undestroyed view because they are not displayed anymore. So there's no point in keeping their view. So their views are destroyed, but the fragment itself can keep its state. And then when you pop back, they're going to come back and get an uncreate view call again. So with all that being said, we can look at the code and we can see that there's only part of the code, but it has an mView field, which is set in onCreate view and cleared here in onDestroy view. However, let's go back. Here it's saying that the field is called mtag. So there's this mtag field that holds on to view, and I'm actually not well. No, is that what's going on? I probably missed something. No, not mtag. What am I saying? Oof. Okay, erase. You did not see this. The name of the field is button login. It's outlined here. This was just some information that surfaced, like the tag of that fragment is login fragment. That may help identify which fragment we're talking about. Anyway, there's a field called button login, and you can see that mView is set to null properly, but button sign up, which I guess is named button login here. So that's also, that's, okay. I lied again. No, I didn't. So they probably renamed the field in between the time they copy pasted and the time between the leak trace and the thing here. But you can see that button sign up is set to some value here and is not cleared in onDestroy view. So that's a common leak. You always want to clear all views and view bindings in onDestroy view. Okay, so let's keep going and get into something a little bit more interesting. I'm getting thirsty. Okay, so what is this leak about? So here we see, okay, the GC root is a global variable in native code. So when you write native code, C code, you can tell the JVM, hey, so there's no garbage collector. At least there's no Java garbage collector in native code, but you can tell the JVM or the Dalvik VM, hey, I'm gonna need this object, so please don't garbage collect it. And so you're creating a reference to it, and then you have to say, hey, I'm not going to need this object anymore, and then it can be garbage collected. And here we have a global variable that is pointing to an instance of text-to-speech connection $1, which is an anonymous implementation of I text-to-speech callback $stub. So if you might not know that on Android, you can talk from one process to another process. You can call another process from your process. It's called an inter-process call. And there's a whole bunch of ways to do that, but one of them is the simplest one is to create a stub. So it's a Java interface that is that both apps know about. And then you ask the system, hey, I want to talk to this process, and this is the interface that this process is going to pretend to, this is the contract, and that is that interface. And then you get an implementation of that interface, the stub, and you can talk to the other process through those method calls. Generally, it can be slow, so we avoid doing it on the main thread if we can. But that's generally the idea. So here we have this connection $1 instance, which is essentially an implementation of an interface that you use to talk to another process. And I bet that's the text-to-speech process that the Android system runs. And so then we can see that this $1, this anonymous subclass, has an outer reference, you can see because it's called this $1, to its outer class, which is a text-to-speech.connection, which itself has a reference to its outer class, which is text-to-speech. which itself has a reference to a context, which is sign of display, but really it is an activity. Okay, so let's dive into a bit more details about like what is text-to-speech. And so there's a new-ish tool that Google released that's super cool. It's cs.android.com. And it's basically the sources of Android, but super easy to navigate, and you can switch between versions. So if we look at text-to-speech, we can go and see text-to-speech. Okay, there's this class called text-to-speech, and I think I can just do a text search like class connection. There's an inner class called connection, and you can see that it has a text-to-speech service. And then look at this. There's a callback created here. It's an anonymous class that implements the stub interface, and it's got a bunch of calls. But you can see that it's a final field. So every connection instance has a reference to its callback, and vice versa. Every call, because it's an inner class, every callback has a reference to the connection. Connection is not a static class, so connection has a reference to text-to-speech. So let's look at. And so then we can see that there's this mContext field somewhere in here. mContext. Oh, well, didn't mean to click here. It's a little bit sensitive, and in context search is not always great. But so context is a final field, and you just pass it to the constructor of text-to-speech. This one is not a public constructor; it's at hide. But these are public constructor, and you can see that it's just passed in. If you look at the code, how do they initialize text-to-speech? They pass in this. Have to assume this is happening within the activity, and so they're creating a text-to-speech instance with an activity context. In and of itself, it wouldn't be a problem if text-to-speech did not survive the activity. And they're saying in onDestroy, I'm calling shutdown, and that should clear everything. And here we can probably look for onDestroy, shutdown, sorry. And you can see that in shutdown, it's unbinding the service. So it's saying, bye-bye, other process, I don't need to talk to you. You can forget about me. And so that should be all right. However, there is a problem. When it comes to IPC, interprocess calls, and when we use those stubs, the stub has a lifecycle that is not directly connected to the service connection. So let me explain. The service, we say, hey, shut down the service. And that actually shuts down the service that was started. But the IPC call is separate from that. And that IPC, and so for the two processes don't really have any notion of like, oh, is there a service running or not when it comes to these IPC calls. What's going on is that the other process, the calling process will keep the reference alive as long as the other process has an instance alive. And so it's only when the implementation of the stub in the other process is garbage collected that the callback will be garbage collected. So essentially, you have to. So let's imagine that the text-to-speech process does not have any leak. So if the text-to-speech process has a leak, then we have a big problem anyway, because it's going to maintain that reference too long. But if it doesn't have any leak, that object, the implementation of the stub, will eventually be garbage collected. But until it is garbage collected, the corresponding stub in our process will not be released. Its reference will not be released. So I'm not sure that I'm being super clear here, but the takeaway is whenever you use IPC, when you know that you don't need to talk to this other process anymore, you should make sure to clear any reference from within the stub, because that stub will be held in memory longer than you want. Okay, so that was kind of a interesting intro to all this. Let's go and look at one more, actually two more, but I'm trying to get into more and more technical stuff. I am hoping that everything's still fine and everybody can still hear me. It looks like I'm still recording. Okay, so let's look at a new one. This one is interesting too. So what do we see here? I see, okay, there's a class called viewGroup $viewLocationHolder. It's not leaking because it's a class. A class is not leaking. Then it has a static field called sPool. That pool has a member field called mPool, and that's an array pointing to a viewLocationHolder, which itself has a mRoot field, and that holds onto a recycler instance that is leaking. It's detached, and its context reference a destroyed activity. Okay, cool. So you might have seen here, if you look at the top, it says 0 application leak, 1 library leak. And then it explains, library leaks are leaks coming from the Android framework or Google libraries. It's a bit of a generalization. They're really leaks from anywhere. But it's basically leaks that we know about, and we wrote a pattern to detect them. And you can actually see the pattern here. The pattern is, if I have a leak that contains this object, viewLocationHolder pointing to this field, then it's a known library leak. And then there's a little bit of an explanation here. In Android P, viewLocationHolder has an mRoot field that is not cleared in its clear method. That was introduced in this commit, blah, 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 bug report. So let's go back here and look at viewGroup or viewLocationHolder maybe. Okay, can I see that? So now we're looking at viewLocationHolder. So viewLocationHolder is an inner class of viewGroup, and it's a helper to figure out views locations when you're trying to do accessibility. It allows sorting the views to know which one is on top of which one, and it's really an inner helper class. You're never using that. It's all within the Android framework. You don't really see it. But what's going on is, because these viewLocationHolders are created every time there's some accessibility going on, instead of creating objects just for like a very short amount of time and then getting them garbage collected, they create a pool. So there's this pool that keeps up to 32 instances of viewLocationHolder, and whenever it needs to go to do this accessibility operation, views are taken from that pool. Sorry, viewLocationHolders, all their instances are taken for that pool, then used, and then they're put back in the pool, which sounds very reasonable. It's actually a fairly common pattern inside the Android framework. And so you can see that this viewLocationHolder has an mView field, mRoot field, and then the static method obtain, tries to get one from the pool. If there's none, the pool is empty, and it creates one and initializes it with the root and the view. And then there's recycle, which called clear, and then puts it back inside the pool. And then clear here is somewhere in here. Clear sets mView and mRoot to null. Well, this is master. What about Android-9? Let's look at, I don't know, 18. Let's see if we can find that clear method really quickly again. There's a lot of clear, but not the right clear. Right, so this is the clear method that we found before. And as you probably noticed, thanks for the help. Julia is telling me it's line 8800. But as you can see here, well, let me check that I'm looking at the right class just to be sure. Yeah, this is viewLocationHolder. And so as you can see, clear sets the view to null, but it doesn't set mRoot to null. And so this is creating a leak, and it's a very, very common issue in the Android open source framework. They have this pattern of using pools to avoid creating temporary objects. And usually when they create that pool for the first time, every field in that object will be cleared in clear. But then someone comes in and say, oh, I need a new field, and they're going to add it and set it, but they forget because it's not obvious. There's a lot of code, and it's pretty common to forget setting it to null. And the result is those leaks. Up to a couple years back, that was annoying, but we could fix it. we would just use reflection and go and set the field to null with reflection and clear the memory leak, and then we didn't have memory leaks. However, starting with Android P, Android introduced the idea of gray list and black list for reflection, which means there are some parts of the Android framework that are not accessible anymore through reflection. And guess what? This view group is part of those. And so that means that, or at least view location holder, that means that we can't clear the pool or clear the leak using reflection. So that was really annoying because now this one bug is actually the main reason I introduced LeakCanary 2, because LeakCanary used to detect one leak at a time and dump the heap immediately. But because this bug was always happening, it was just continuously dumping the heap. And so I introduced this idea of buffer, waiting for 5 leaks before doing a heap dumps. Because that way, even if you have 1 or 2 leaks in the Android framework, it's going to wait for you to have more and hopefully your own leaks before it dumps the heap. Anyway, so that's where we are, and that's kind of where we were until not too long ago. But last week I released LeakCanary 2.4, and with that version comes an interesting thing. It's something that I've been wanting to do for a long time, and I'm glad I finally did it. And it's essentially, it's a new artifact called Plumber Android, and it is a way it's basically code that will automatically fix the leaks for you. So let's get to that in a little bit. I'm going to point you to the latest release. So you can see 2.4, and there's a new artifact, Plumber Android, that will automatically fix a number of known memory leaks in Android. Not all of them, just like I think it's 11 right now. When you upgrade to LeakCanary 2.4, automatically those leaks are gone in debug, because LeakCanary is debug on it. It's basically a dependency that's included automatically. However, in your release builds, you don't have LeakCanary, hopefully, which means you don't have that dependency, so you're not getting those fixes. So the only impact for now, if you just upgrade to 2.4, is that you will not see this leak being reported anymore at all, and it will not trigger a LeakCanary because it's fixed. However, if you think you'd like to see that in your release builds as well, there is an artifact that you can add, which is Plumber Android. This is the first release. I'm going to test it out with, I'm testing it out with Square apps. You're welcome to use it, but be aware that it might crash. Yeah, I guess I'm taking a long time. Great news, the event has been extended. Sorry, it's a lot. So I'm going to quickly go over the fix, because I think it's interesting to look at how do we fix this. So there's this class called if I can Android leak fixes. It's actually an enum with a bunch of fix, and there's one called group something view location holder. Right, and so this is the fix, and I'm gonna go through it not too fast, but how does it fix the leak? So it first registers an activity lifecycle callback to know about every activity that's created, and then whenever an activity is destroyed, and whenever an Android X fragment is destroyed, we call this method called uncheck clear static pool. What is it doing? So there's initialization at one time, and what it does is create a frame layout with 32 children. 32 should ring a bell because it's the size of the pool. So these children are a simple view, and the really interesting piece to notice is that mContext here is going to be the application class. So the application class is a singleton. We don't care about it being retained. It never leaks. It's always in memory. And then what do? We call this method called add children for accessibility with that view group. And then if you actually go into the source, you can see that it calls child list for accessibility.obtain, which itself calls, so that's another helper class, but it calls init, and then init here calls view location holder.obtain. for each of the children of the pastine view group. So we added 32 children, so this is going to happen 32 times, and it's going to call obtained 32 times, which means that the entire pool is emptied, and then as soon as the operation is finished, all of these views are put back in the pool. So we basically just swapped out everything that's in the pool with other views that we don't care about leaking, effectively removing that leak. And then, so that's like an interesting fix. I think the last one I want to quickly go over, but I probably won't spend too long on that. It is the craziest leak that you've ever seen. And it's been happening in Android forever. It's not visible in the Android source code. It's probably a VM bug. It's really hard to fix. But let's talk about it. So on Android, you have this concept called a handler thread. Handler thread is just a thread, and essentially it has a queue associated to it. And when you create a handler and you do handler post, you're actually adding work to that queue. And then the handler thread is just a loop, and it blocks, waiting for some work. And as soon as there's something, it takes it, runs that message that you posted or that runnable, and then look at the next one in the queue. Pretty straightforward. Now, so we see a handler thread here, and it says, well, your thread has a Java local reference. So local reference means it's not a field. It's actually the thread is running, and somewhere in the thread stack, there's a reference. There's a local variable that's referencing an object. That object is a message. That message. So messages is how you communicate with a handler thread. When you do handler.post, you're actually creating a message object, which has an object field set to a dialog. And I'm hearing beeps, so I'm just make sure. Yeah, it's just Jean-François talking to me. Great. So that. Oh, I'm realizing that no one said anything, but you guys, I'm showing you the wrong screen. Okay. You should complain. Yes, thanks, Julien. I only see your ID. Great. Okay. So this is what it is. Handler thread. So there's a handler thread. It has a local variable to a message. Message has an object, which is a dialog. And we know that this dialog is leaking. And the person is asking, like, what did I do wrong? And the unfortunate thing is that you didn't do anything wrong. And Android did something wrong. We don't know exactly what. But what's going on here? So what you did wrong, actually, no, there's one thing. You basically should never use dialogues if you want to avoid those leaks. You should either not use dialogue or not use handler threads. But a lot of libraries, including Play services, stuff like that, they use handler threads. So basically, it means you should never use dialogue. And this gets a little bit tricky. But what's going on is when a dialog is created, it actually obtains, so message is in a pool similar to the pool we just saw. It's a synchronized pool. So that because it's always getting new messages and pushing them back in the pool. And this dialog here, when it's created, it gets a message from the pool and creates puts its on-click listener inside the object field, or puts itself, inside the object field. And itself has a reference to its listener, and the listener has a reference to the context and the fragment, and then it's leaking that fragment. However, the key interesting piece here is that when this message is recycled, object is set to null. So this shouldn't be a problem. However, the way dialog has a bug, it's implemented in a bad way, and they've never fixed that, unfortunately. And what it is, it's not really a bug because in theory it should be okay. It is that the message is never recycled. So what happens is that the dialog creates an instance of that message and keeps it around for when there's going to be a click and it needs to post something. But sometimes it never needs to post it. So it's just going to keep it around forever, just never put it back in the pool. And that shouldn't be a problem, really. It's fine to never recycle an object from the pool. However, this is where it gets tricky. So eventually that dialog is not referenced by anything else and should be ready to be garbage collected. and that dialog has a message, and that message itself is referencing the dialog as well. However, the problem is that message is a faulty message. And so what happens is, prior to the dialog pulling the message from the pool, the message had already been used by the handler thread. So there's this handler thread that's asking for a message, or basically being, there's a message posted to it, it receives it, it executes it from, it pulls it from the queue, executes it, and put it back in the pool. And then the dialog takes that message and creates an instance of it. So when the handler thread puts it back in the pool, it should be fine. However, the handler thread also keeps a reference to that message that it put back in the pool. Why? Well, this is where it gets really weird. You actually cannot find the code where the handler thread is keeping that local reference. It's just a loop, and at the end of the loop, it's doing message recycle, and then the next line goes back to the top. It's message equals, give me a new message. But when the handler thread has no new work, then it's blocking on that top call, waiting for a new message. And the VM will actually keep active the reference to the previous value of the message. And that doesn't get fixed even if you try to set it to null. It's just most likely a VM optimization. What that means is that as long as this handler thread is, so for this to happen, you need a couple of things, right? You need a handler thread to get a message, then it puts it back in the pool. Then a dialog happens to get that specific message, and then the dialog is gone. And that handler thread needs to not have any new work since it put back the message. So it's a lot of very special conditions which make it hard to reproduce. But when it happens, it's really hard to fix, right? Like, what are we gonna do? We could stop using dialogues, or we could do some magic. And this is where it gets fun, here, and that's what I wanted to show last, flush handler threads. So this one does not use reflection. Oh, did you lose the image? Oh, no, you didn't. I just switched again, and you need to see this. Is it better now? Yes. Okay, great. So I'm showing you another fix that is in Plumber Android, which is kind of crazy. So what is it doing? Every 2 seconds, we try to find all of the new handler threads that have been created recently. Or every 3 seconds, I guess, wait 2 seconds. So how do we find all handler threads? Well, you can find the current thread, then find its group. You can go then up the thread hierarchy until you find the root thread group. And from that, you can then go down and actually go through the entire hierarchy of all threads in the VM. So it's a common trick to find all of the existing threads at that point in time. And then we find all of the ones that are an instance of handler threads, and we return that. So already that's pretty insane. So we have all of the new threads, and then we find their IDs, and we keep a list of the thread IDs that we've seen. This is just so that we can detect new threads versus existing ones that we've already done some tricks on. And then for each of those, we create a handler. And every time the thread is idle, which means there is a chance that it's holding on to a message that should be back in the pool. Every time that it's idle, we say, all right, well, in 1 second, you're just going to do something. And this is what this is doing. And what is it doing? Pretty much nothing, just recording that it's doing something. And that's it. So what that means effectively, this fix, is that there are no, the handler threads cannot be idle for more than 1 second anymore, which means the leaks are going to be at most 1 second long. It's a bit of a crazy hack. I think it might be scary. If you're worried about performance, I don't think posting an empty message every second to a message thread is actually that big of a deal. Especially that shouldn't impact like the main thread, which is running all the time anyway. So this is a little bit scary, but it does the work, and the leaks mostly go away. We found they can still happen if you like run a really quick UI test in between the thread detection and that kind of stuff. But in debug apps, it's gone. All right, so that's that's the conclusion. That's everything I wanted to chat about. And so with that, I can see the chat, I can see the Q&A. Oh, wow, there's a bunch of questions already. So yeah, I'm going to start the presentation here. I'm going to start answering some questions, going through them in order. So you can switch to that Q&A tab and upvote, downvote some questions, and I'll try to see if there's new chats at any point. Okay. So top question, do you use Shark CLI with continuous integration for your apps? I don't. So Shark CLI returns proper status code. So you know if it's successful, if it found something versus not, it should, I think, return. I'm actually not sure. I think it just returns success all the time. So you'd have to parse the success if there's no error in parsing and everything. So you'd have to parse the output. I didn't think about using that for CI. The way that we currently set up CI is we have a test listener that waits for the end of the test, and then within the Android VM looks for leaks and makes the test fail from within the Android VM. It's an interesting idea to use the Shark CLI for that. It probably wouldn't work with something like Firebase Test Lab because we don't have access to the environment where we run those things. But that might be interesting for some other CI configurations. I'd love to get, if someone's trying and something's in a way, we could talk about making changes to Shark CLI for that. In theory, LeakCanary should work with projects built with Flutter, React Native. Do you know if people are doing it and if it's useful? So are people doing it? No idea. I don't really get anyone calling me when they use LeakCanary. However, actually, I'm going to do a little bit of a parenthesis here. On the LeakCanary project, there is a dedicated issue called Guestbook. And so you can leave a testimonials there. Like if you use LeakCanary for your app, you can drop a message and say, hey, I'm using it for my app. It's just cool way to leave a bit of a note and let the team know that you've been using it, you enjoy it, and all that. You can still use other issues for feedback and things to improve. This is just a guest book. So, and this is similar to a question about, there's also a question, LeakCanary, can it be used with progressive web apps? So Flutter, React Native, progressive web apps. You can set up LeakCanary in Flutter apps and in React Natives. I don't think you can with progressive web apps. The question is, should you? Would that be useful? Well, LeakCanary is focused on a Java-based VM. So what it does is create weak references in Java to objects that should be garbage collected. Then it has an API to trigger a heap dump, which is a copy of the Java memory, a copy of the Java memory on a file, and it knows how to parse that and find the leaks in there. When you're using Flutter, it's a different VM with there's very little. There's some Java, but very little in terms of your application code, or none at all in terms of your application code. React Native, same idea. It's a JavaScript VM. Progressive web apps, same idea. It's it's a web app, but really it's just running a JavaScript engine. So the answer is no. It probably doesn't make sense to use LeakCanary in those. That being said, the concepts make a ton of sense. Anytime you are using a VM with garbage collection and there's lifecycle based on whether there are references to objects, it makes sense to have something like LeakCanary. But you'd have to build that. You need to build something that can track references. You need to have objects with the lifecycle so that you know when they're supposed to be gone. And then you need an API to do a heap dump of some sort related to that VM. You need to parse that heap dump, and then you need to show that in the UI. So that's a lot of steps. I believe it could be done for JavaScript, for Chrome. And if memory was an issue, someone should look into it. I'm happy to chat about it. I don't really have the time nor the skills to attack a new environment like that. Is Shark CLI available on Linux, Windows? If not, is it on the roadmap? It's a great question. So I showed a command to install it, which is brew install. That's for Mac, and I don't think it works on Windows and Linux. That being said, Shark CLI is actually just a jar, and so you can run it. If you go on GitHub in the releases on GitHub, you can actually download sharkcli.zip, and in there you will find a jar with all the executables to run it on Mac, Linux, and Windows. So it's not going to be as easy to install. I.e., you still have to, basically you have to download the zip, unzip it, run the command instead of just brew install and then you can run it. But yeah, it is available on those platforms. In sharkcli, the analysis log can be exported as JSON for future use, like in CI pipeline. So that's the same question. You could, I mean, it's out there. You could parse that. You could also write your own extension or contribute something to sharkcli so that it works with your favorite CI environment. But by default, not really. But really, it's always like I just don't have the need right now. If someone has the need, they want to write the code, we can talk about it. I've had a few leaks because of late init var. Is this a real leak? If so, how to prevent it? So it's really hard to answer that question without seeing the leak and some of the source. But if it's a late init var in a fragment and it points to a view and you set it in onCreate view, but you don't set it to null in onDestroy view, then yes, that is the problem. It needs to be cleared in onDestroy view. In general, late init vars are not special in any way. So it's mostly about, you have to think, am I keeping a reference to an object after that object has reached the end of its lifetime? If the answer is yes, then you need to figure out how to clear that reference. Are Android SDK developers using LeakCanary on the SDK? I do not work at Google, so I unfortunately do not have any official answer to that question. I know there are a number of Google apps that use LeakCanary, and I don't know exactly which ones. I don't believe that the Android open source framework is actually using LeakCanary internally or on new versions. I believe they should, but also it's a big company with a lot of people doing different things. I don't have the ability to tell Google what to do. I can hint at it, I can advise. I'm happy to talk to anyone interested, but I've hinted at it several times pretty strongly, and I think people are interested, but there's basically no one in charge of memory leaks at Google. There's a performance team, and they think about this, but they have a lot of scope and a lot of things to think about. And so they approach the problem with a different angle. Is LeakCanary fully integrated with RX Java 2 lib? Well, yes and no, in the sense that LeakCanary is just integrated in Android apps. It has, so I think I see what you're hinting at, but LeakCanary doesn't have to integrate with any specific library. So it will work with all the versions of RX Java that you use and all that. However, it can have specific knowledge about a library, like how it knows that fragments are supposed to be garbage collected when they're destroyed, or how it knows that a mortar presenter has this field called M active or whatever. And so similarly, you could imagine some code inside LeakCanary to look at the RxJava state and decide, oh, this is leaking, this is not leaking. We have some of that internally. We actually use it mostly to surface extra information, but I haven't published that because it's not quite in a good enough state. And I still I basically need some more I need to see leak traces and heap dumps where RxJava is at the core of the problem to understand how we can make that more useful. What are the most common leaks that you see? The one that was the most common for the longest time, or I think it's still the most common, is the fragments that are put on the backstack and they receive the onDestroy view callback, but there's still a field in the fragment that is referencing a view, and that field is not set to null. It's by far the most common one. But I think people are starting to realize what's going on, and with LeakCanary, I'm trying to output some more information about how to fix it. We also recently, it's interesting, I added support for detection of leaks of view models, because they also have a life cycle. They receive uncleared, and after uncleared, they should be garbage collected. And it works really great, but no one has reported a leak. So in Stack Overflow or anywhere. So I don't know if it's because view models are not that used, or by design, they make it harder to have leaks, which I suspect it's actually that. I suspect that view models it's much harder to have a leak with a view model than with a fragment. Fragments tend to make it easy to make mistakes. Is there a public library full of leaks that you don't recommend to use? Android. That's it. I'm kidding. Obviously, we have to use the Android framework. But yeah, you. No, I don't have anyone specific in mind. I think there's. I guess the only one that I see recurring is Glide. There's a known leak in Glide, and it's because it has not an infinite duration. Its duration is for some amount of time. The author has not. Well, he's got a lot to do and hasn't fixed it, and so this one keeps popping up in Stack Overflow. But I don't know that Glide has many leaks. It's just that one. Maybe it'll be fixed eventually. I noticed that in the chat, someone said you can set a late init var to null, which is true if that field is of a non-nullable type. So it's going to be up to you to set it to a nullable type. But yeah, I mean, I guess you're right. If it's a late init, the whole point of late init is to use non-nullable types. So yeah, you basically should not use late init and instead should a var of a nullable type for that. What DI library do you recommend? Memory friendly? That's not the point of this talk. We still use Dagger 2 at Square. I'm pretty happy with it. I think I saw that. So I don't want to get into the DI war. I'm not using Coin. I think Coin has a great documentation. Dagger has a shitty documentation. I like the behavior and the internals of Dagger. I also think Dagger has Dagger has a lot of poor UX. Like the documentation is bad, the errors are pretty bad. It's kind of hard to, and it's got way too many features that you probably shouldn't use. I looked at Hilt recently. I saw some blog posts that I'm not going to comment on, but are pretty shitty. But overall, I think Hilt is an interesting move. It's much more positive than Dagger Android. There's a few things here and there that we could change there, but I think it's going to make things simpler. And it's a pretty big trend to use the class pass. We're also doing that internally. We have some libraries coming that are going to do that as well. To use the class pass to determine what to put in your component instead of having to manually link. So that's cool. I think. What else? Yeah. How is the life in Silicon Valley for a froggy? So froggy French. It's used to be pretty great until I guess COVID. Still pretty great, but we're staying at home. The overall, it's really nice. I think there's a kind of a transformation right now. We always knew that the future was remote, and so there's this question of like, how do we get there? Silicon Valley tends to attract a lot of people who come to work in those hot tech companies. And with a move to remote, maybe there's going to be less of that. And COVID-19 has actually accelerated that move. So I believe we will start seeing change, and I believe some companies will not change. I think like Apple will fight against remote as much as they can, for example. Some companies will go, and we're trying to go with that change at Square, I think Twitter as well, and try to basically move into a world where everybody is remote. But we'll see how it plays out. But overall, it's really nice. Like it's, when you're in San Francisco, you're in a city, you have access to a lot of fun stuff, but you can also go out the city and, hike. You can go skiing in like 3-4 hours of driving. And you can go surfing. You could go surfing on Saturday and skiing on Sunday, which is pretty cool. Yeah, I really like it. I also love working, at Square. I think it's a great company, but overall, like San Francisco is an interesting place to work at. Great coffee. I don't know what else to say. I don't know that as a French person, there's a lot of difference, I think. Overall, here people are pretty open. They love to chat, which is a bit weird for French people. Like you'll talk to someone, you'll be in the street, and someone talks to you and say, "Hey, how are you?" And then they talk about their life, and then 5 minutes later they leave. Can you share your video setup? how could I do that? I might try. So basically what I've got is I've got my X-T2. It's a mirrorless camera that I put on the thing, and then it's filming me, and then I have a so I have a converter. I have a little device that converts HDMI in to USB out, so it's kind of like a webcam. Well, it turns basically an HDMI output into a webcam, a USB webcam. So the computer thinks it's a webcam. Here I have a Yeti and a pop filter for the sound. I think I can try. This is going to be risky. That's you're asking me to do stuff that's going to be. Oh, I'm really stupid. I think. Yeah, maybe. Yeah. Well, and then how do I show? No, that's completely stupid. You know, it's funny. My brain is not working right now. I'm thinking, how do I show the camera? And then I'm showing the screen to the camera instead of showing the camera to the camera, which I can't do. I wish I had a big mirror. But that's pretty much the idea. I tweeted a picture of it the other day. Yeah. Oh, and the camera, I set it to autofocus. So as I move around, it should, focus more or less on me, which is also pretty cool. A few words in French. Je ne parle pas français. Just kidding. I don't know what should I have no idea what to say. It's funny because when I come back to France, sometimes people tell me that I have an American accent, and here obviously people tell me that I have a French accent, and so I get a little bit confused. And as you speak in English every day, you tend to lose your vocabulary, and people will think that you're like trying to speak with an American accent or using weird words and all that to make yourself, to look important. It's not the case. It's just that you forget the vocabulary. It's just easier to use the words that you use every day. As an open source developer, what kind of tips can you give us to make successful libraries? So I think one thing that is very often overlooked is, might sound like a swear word, but marketing. And an open source library, well, it depends. It depends what you're trying to do. Like, if you're just sharing the code with the rest of the world and you don't care if someone uses it or not, just do that. If you think that the work you're doing is good and that more people should be aware because more people should use it because it would benefit them, then you want to have more adoption. And if that's the world that you're in, then you have to think, okay, this is like a product. It's what we do here as well, like at Square, and it's everything I've learned about building products, I try to apply to open source as well. So that means, okay, when someone comes in, what are they trying to do? Hopefully we don't talk for another 30 minutes, but what are they trying to do? How do I guide them? It's like a funnel. It's like onboarding on a website. I want them to read this, and then I want them to read that. And I know no one reads the documentation. So how do I make it easy to navigate? How do I remove as much content, but also have way to go find more content? And so all of this is really thinking about, and so that's like it's stupid shit. Like having a cute logo actually helps. Having easy to read documentation. Like I mentioned Coin. Again, Coin has, it's got its own merit on the technical side. I don't want to talk about that, but Coin has a fun logo, good documentation. All of that actually has value. It makes the things more approachable. People will remember it. The name is fun. And so I think it's actually important to think about these things because people will remember it. They'll pay more attention to it. It's not about having marketing for empty content. It's the same thing with tech talks. If you're just being very boring and reading a book or something, then you're losing the audience and your message is not getting through. So it's important to think about the packaging, about having a nice message that people pay attention to so that they actually remember what you're trying to say and they learn from that. And what's a good way to start contributing to open source libraries? That's a really good question. So on GitHub, you'll notice that there's a new tag that a lot of libraries are starting to use called Good First Issue. We have the same on LeakCanary. We also have Help Wanted. So for LeakCanary, when you go to the website, you will see and the top there's like, oh, here's how you can help, and I welcome help. And helping can mean responding to issues. It can mean opening up a pull request. It can mean helping on Stack Overflow. It's basically being part of this community. I think the first thing to do is do it. Generally, it's nice to do it on a project that you're familiar with, that even if you don't know the internals, but that you like, that you're interested in, where you kind of have some vested interest. The best contributions usually come from someone having a bug and wanting to fix it, and they start digging, and then it's but you could just look for projects. There's a bunch of think about all the projects you use and go see their pages and go find some issues. And it's actually an interesting, like, reading source. The way you get better at code is by reading a lot of code. It's one of the ways anyway. And doing that for open source, you can learn so much from looking at how open source libraries are architecture and what the internals look like. All right, that was a lot. I'm going to start with oh, thanks. Yeah, Jean-François shared the tweet where I posted a photo of the setup, which I think I can then, okay, so let me see. If I do this, and then I do this, you will see it in about 1 second. I mean, you probably already clicked the link, but no, that's not where I want it to go. Here. Yeah, that's the setup. So this is kind of a reverse view of what you're viewing right now. Cool. So with that, let me find where's the chat that we were going. All right, that's all for me. So thanks a lot for being here, for attending. I think Jean-François will take over, but thanks again. It was really cool to try this out. I can't wait to do some more of this. Don't hesitate to reach out on Twitter. Don't hesitate to file GitHub issues. Bye-bye, and take it away. Oh, and you can turn on video and audio if you want in those little rooms where we are. You don't have to, but you can. All right, bye.